3.3 Differentiating inverse functions. If you recall, a function's inverse is found by swapping the input or x and output or y values. Some confusing notations. Reciprocal notation, which is, so this is the inverse of x, which is like 1 over x, or this inverse of f of x, which is the inverse of the function, or just g of x. So make sure not to get these confused or mixed up. They're two different things. 3 ways to say the same thing. 1, g of x is inverse of f of x. 2, g of x equals inverse of f of x. Or f of g of x equals x and g of f of x equals x. Derivative of an inverse function. So the derivative of the inverse of f of x equals just 1 over f prime of g of x. And this also equals the derivative of g of x. The table below gives values of the differentiable functions f, g, and f prime at selected values of x. Let g of x be the inverse of f of x. So you could use the formula, but a much easier way of doing it is just creating a table of values. So x, g of x, and then g prime of x. Creating a table of values, switching the y and x values. So right here, if this is the x value, over here the y values are 1, 2, 3, and 4. And then the y values over here are the x values, which is 3, 1, -5, and 0. And the values of f prime over here are just 1 over whatever number this is. So negative 1 over 3, -1 over 2, -1 over 5, and -1 over 6. So now that the table's here, we can just answer questions without really having to do work. So what is the value of g prime of 1? So we go to our table. When it's 1, what is the value? -1/2. Write an equation for the line tangent to the inverse of f at x equals 1. So inverse of f at x equals 1, so is looking at the middle column at x equals 1. So our point right here is 1, 2, and our slope is -1/2. So knowing the point and the slope, we just plug it into the point slope formula. Y minus 2 equals the slope, -1/2, multiplied by x minus 1. 3. Let g be a differentiable function such that g of 12 equals 4, g of 30 equals 6, g prime of 12 equals -5, and g prime of 3 equals -2. The function h is differentiable, and h of x equals the inverse of g of x for all x. What is the value of h prime of x? Same thing here. We could just draw our table of values. So the original function, g prime of x, and then our table of inverse function, h of x, h prime of x. The values they tell us: 12, 3, 4, 6, -5, -2. And we just swap values, so 4, 6, 12, 3. We'll have 1 over 5, -1 over 2. Now that we have the table, what is the value of h prime of 6? So h prime is the inverse of g prime of x. So we're looking at this column, and when x is 6, so 6. So h prime of 6 equals -1/2. Same thing over here, except this time they give us a formula. It's not much different. 3x cubed plus 1, and then the derivative of 9x as 9x squared. So we plug in our x value. Oh wait, first let's draw our other table first. If g of x, g prime of x. First things first, we know that the x value is 25 on the inverse, so that means the y value of here is 25. So you solve for 25 equals 3x cubed plus 1. You'll find that the answer that is x equals 2. So now we know the y value here is 2. And you plug 2 into the derivative function. So 2 squared is 4 times 9 is 36. And that means right here is 1 over 36. So g prime of 25 equals 1 over 36. Very easy.